All right, everyone, here we go. We have Unit 9, and I know we're going to be using Worksheet 1, okay? I put this under the notes, but it is also your Worksheet 1. In order for me to introduce you what Unit 9 is all about, Unit 9 is all about logarithms, okay? But in order for me to introduce you to Unit 9, I need to start with Worksheet 1, okay? So we're going to start with Worksheet 1. I am going to assign some homework from here, but I'm going to do a lot of them as the notes for this objective, okay, for objective 1. So objective 9.1. It is called the what power function. That's what logarithms is actually all about, is what power. Okay, so when we're talking about power, we're talking about exponents. Okay, so what power, what exponent. So because we're talking about exponents, I went ahead and I put here on the side the rules of exponents. Okay, so you maybe need to take a little bit of time, and you need to maybe pause the video and write down your rules of exponents. We are going to be using these rules of exponents a lot because that's what powers are, especially the more challenging ones, such as a rational exponent or a negative exponent. Okay, so these ones are the ones that the students usually get a little bit confused about. So I put them right here. They're super important. We are definitely going to be using it. Okay, so that's just our side note here to be prepared for what power. All right, let's get started. What is this asking? It says evaluate each expression using the what power function. The first 3 have been completed for you. So this is what it's saying. What power should I take this base number over here? Let's call it base because the tiny little base right here. So what power should I take this base number right here to get a 25? The answer should be 2. In other words, 5 to what power? Let me put a little box in there. 5 to what power will equal 25? So this is my little base. That's why I put it here on the bottom as the base. 25 is our answer, so let's call it A. A for answer. And I'm trying to find the what power. What exponent should I take it to? And the right answer should be a 2, right? So that's why I should go inside of this tiny little box. Should be 2. 5 squared equals 25. So what power should I take this base number right here, 3? 3 to what power? Let's put a blank. Will equal this answer of 27. Well, they told us it's 3 because we know that, right? So we can even put in here so we know, oh, it's 3. 3 cubed gives me 27. Okay, one more time. What power should I take the base number 2 to, let's put a big old box, 2 to what power gives us 16. That's the answer, but we're looking for the exponent. So the exponent should be a 4. So they do the top ones for us. So we understand what is it that they're looking for. We're looking for the power, the exponent. The better you are with exponent, the quicker this is going to go through. And it's not about being quick. It's about the better you are with exponent, the better you understand logarithms. So maybe for some of you, you need to take a minute and write down a few basic exponent list. You can do 2 to the 0, 2 to the first, 2 squared, 2 cubed. Make a little list of those. And then make 3. 3 to the 0 power, 3 to the first, 3 squared, 3 cubed. Maybe do those. And then maybe do the 4s and the 5s. That's enough, okay? Maybe a couple of 6s. Just do a few for you to know what are the answers. Let's go ahead and do it. 2 to the 0 power is 1. Anything to the 0 power is 1. Anything, right? Well, except 0, but that's a long discussion we would have to have. You would have to come to my intervention hours. Okay, what would be 3 to the 0 then? Well, anything to the 0 power is 1. Any number to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. 2 cubed is 8. I want to challenge you to go all the way to 2 to the 10th power. Okay, 3 to the first power is 3. 3 squared is 9. 3 cubed is 27. I would challenge you to take all the way to 3 to the, I don't know, try to the 10th. Might be too large, but whatever. Okay. So maybe you need to do that on the side, your little side notes. I suggest you memorize them because, okay, it's a good skill to have, just like multiplications, right? So let's go back here. What power? 2 to what power will equal 32? Well, take your time, discover it. It's 2 times 2 times 2 times 2. How many times is to the 5th power? Okay. All right, let's do a few more. Let's see if we can start getting gooder and gooder. Okay. What power? 10 to what power will give me 100? That would be 10 squared. Okay. 10 to what power? Let's put a y. I know you want to put x's, but let's put a y, okay? Because y is the variable, I don't even know why. You'll understand why later. So 10 to the y value will equal 1,000. Well, I know 10 times 10 is 100, times 10 would be 1,000, so that's 3. Okay. 4 to what power? Let's put a y there. Y. 4 to what power equals 64? 4 to what power equals 64? Think about it. 4 times 4 is 16, times 4 more is 64, so 3. Okay, let's do another one. 2, let me put a y to what power will equal 64? Now that's 2 times 2 times 2 times 2. Do it. Come on, you can do it. Figure it out. 2 times 2 times 2. How many times? It would have to be 6 times. Okay, especially if you create your little list, right? 10 to what power will give me 10? Let me see. 1, 2, 3, 4. 4. 1, 2, 3, 4. Oops, sorry, my zeros are all messed up. So to the 10,000. Well, look at how many zeros we had here. We had 1, 2, 3 zeros. Our answer was 3. So 1, 2, 3, 4 zeros. My answer is going to be 4. Okay, 10 times 10 times 10 times 10 will give me 10,000. Okay. All right, now it's getting interesting. If you thought like, oh my gosh, this is going to be boring, I'm going to walk away, come back. Now it's going to get interesting. Right here is where it gets interesting. What power should I take a 5? Let's put a y. So 5 to the power of y equals the square root of 5. Well, that's hard to tell, right? Until we come back over here to this rule, the rational rule. Okay, how do I get a square root? Oh, it's because I have a rational exponent. So it has to be a fraction. So how do I rewrite this as square root? That would have to be 1/2, right? So the y value is 1/2. That makes sense because if I write my exponent, look at this rule right here, my exponent is 1/2, then it would become the square root of 5. Okay. All right, what power do I take a 9? 9 to what power? It gives me 3. Well, how did I go from a big base to a small number? How did I go from a big base to a small number? I should have probably have done something like a negative exponent. No, that doesn't make sense. Oh, a square root? The square root of 9 gives me 3. How do I write the square root? By now you should have noticed that square root power, okay, can be written as 1/2. So the answer for this is 1/2. It makes sense because if I write 9 to the 1/2 power is the same thing as the square root of 9, which is 3. Okay. Again, big base, I'm going to have a small answer. How is that possible? 8 to what power? It's going to give me a small answer. It's not 8 squared because 8 squared would be 64, right? So how do I get a small answer? Again, okay, it must be a rational exponent. Is it the square root of 8? Nope. Is it the cube root of 8? Yes. 8 to the 1/3 power is the same thing as the cube root of 8, which is 2. So this is 1/3. All right, it's getting interesting. Number 13, 42 to what power? 42 to the power of y will give us 1. Well, I know 42 to the first power is 42. Well, let's write it right here. Right here. 42 to the first power is 42. 42 squared, I don't even want to think about it. I'm going to have to use my calculator for that. So it must be 42 to the 0 power to give me 1. So what power is that? 0. 1/2 to give me 1/8. My base now is 1/2. Don't get confused when the exponent with the power is 1/2 or 1/3. My base is 1/2. So 1/2 to what power will equal 1/8. So 1 to that same power and 2 to that same power will equal 1/8. What would that be? Well, I know that 2 squared is 4, 2 cubed is 8, so that would have to be 3. 1/2 cubed, it is 1/8. Okay, because you cube the numerator and you cube the denominator. Again, let's do it one more time. 2/3 to what power, I'm going to put a y, will equal 4/9. Well, I know 2 squared is 4, then 3 squared must be 9. So the answer is 2. All right. All right. How do I get now a whole number base? 3 to what power will give me 1/3. Now my answer is a fraction. My exponent, what exponent would I have to have for my answer to be a fraction? Don't you worry, we got you covered right here. Okay, my exponent has to be negative for my answer to be a fraction. Don't be confused with my exponent is rational here. Okay, so what would I have to do? I would have to take it to the -1 power to get 1/3. It makes sense. 3 to the -1 does equal 1/3. Okay, so 2 to what power, let's put y, will equal 1/4. It's going to have to be a negative exponent. What would that be? That would be -2. 100, oh my gosh, who put that here? 0.01. Well, let's think for a minute, right? Let's think. ... We're thinking. How do I switch a decimal to fraction? 0.01, that is 1/100th. Oh, that's how you write it. Oh, silly. Okay, so this is just what power do I take the 100? 100 to what power will give me 1/100. Okay, so the decimal is just 1/100th. So what power would that be? -2, because I know 100 to the -2 power will be 1. Wait, I made a mistake. It's -1. Sorry, -1. -1. That'll give me 1/100. Okay, there we go. Nice. So I hope you understand that we're going to be using some negative exponents. We really didn't use the top ones right here, or this one right here, or this one right here. I put it there, but we definitely use negative exponents a lot, and we definitely use rational exponents. Okay. All right. Now let's continue. Write a definition for the function what power of b, a, where b and a are numbers. Well, based on what I have been doing here, we'll start saying b, which is the base, to a certain power equal to a. That's how we started right here with number 1, number 4. Then we start to use a variable. We said b to the y value equals a. So that's what we want to be thinking about. Okay, so we let the y is representing the power. Okay, that's what the y is representing. So b to the y power equals a. Okay, that's what the definition that we're using right here over and over again. All right, So what I would like for you to do is to take a moment to do the easy ones. I'm going to be nice. Okay. I want you to do number 19. I'm going to put you. You're going to do number 19. You're going to do number 20. And you're going to do number 21. I'm going to let you do the easy ones, and I'm going to go over the harder ones. Okay. So you're going to do 19, 20, and 21. Here we go. I'm going to do 22. What power should I take this base? So 0 to what power equals a 7? Well, let me think. All right, let's think here on the side. 0 to the 0 power. Let's not talk about it. There's some mathematicians still arguing about this. Let's leave it alone. 0 to the first power is 0. 0 squared is 0 times 0, which is 0. 0 cubed is going to be 0. 0 to the 100 is going to be 0. Is it ever going to give us a 7? No. So we write no solution. So there's something funky about, can the base ever be 0? Let's put a big question mark here. Something doesn't smell good here. All right. What power, 1 to what power will equal 12? Well, let's think. Let's think over here on the side. 1 to the 0 power, that's a 1. 1 squared is a 1. 1 to the 1 cubed is a 1. 1 to the 100th is a 1. So we always get the answer of a 1. We're never going to get the answer of 12. So that's also a no solution. So there's something funky about the base being a 1. What power can I take the -2? Okay, -2 to what power is going to equal 16? Well, let's think. Think. So -2 times -2, which is -2 squared, equals a 4. -2 times -2 times -2 equals -8. So it is possible to get a negative answer, okay? As a matter of fact, I can keep going. -2 times -2 times -2. It's possible I'm going to get a 4. So there's nothing wrong with negative base, right? So let's put a happy face here. Happy face, there's nothing wrong with negative base. All right. What power should I take a -3? -3 to what power gives us 27? Well, I know that -3 squared is a 9. Let me put it right here on the side. I know that -3 squared is a 9. I know the -3 cubed is a -27, but not a positive 27. So I'm never going to get this. So that's a no solution. Well, a minute ago, I was happy about having negative base, but now I'm not happy anymore. So negative base sometimes works, sometimes doesn't work. So something doesn't smell good here, okay? Sometimes it works, sometimes it doesn't work. So not good. Let's move on. 8 to what power? 8 to what power will equal 0? Honestly, nothing is going to ever equal a 0 because 8 to the first is 8. 8 squared is 64, right? 8 to the 0 is 1. So it's never going to give me a 0. That's also a no solution. So something funky here. All right. And a 5 to the -5 to what power will equal a -25? Well, 5 squared is 25. 5 to the first is 5. I'm never going to get a 25. So there is no solution. So there's a lot of funky things happening here. The answer inside cannot be negative or 0. The base cannot be 0, cannot be 1. I don't like negatives. Something funky sometimes happens, sometimes it doesn't. Sometimes it works, sometimes it doesn't. So based on this, examples that we saw, okay, based on these examples, we can come up with two conclusions, okay? We can come up with two conclusions: that our base B, the base cannot be 0, cannot be 1, but it can be positive numbers, right? Oh, it cannot be negative either, right? Negatives are unstable, sometimes works, sometimes doesn't work. 0 cannot happen, and 1, it's no solution, because everything 1 to any power will always be 1. So it's really not happening anything interesting there. So how can we say not 0, not 1, and not negative? Well, we say we want the base to be greater than 0, meaning no negative and no 0, but I also want to exclude the 1. So we say that it has to be greater than 0 and it cannot equal 1. So everything in between is okay. For example, I'm going to do a number line for us to see. We said it cannot be negatives. Okay, so I'm going to highlight the negatives. I'm going to put a 0 right here. So these are all the no. The base cannot be negatives. It cannot be 0. So we're also going to scratch the no, the 0 here, no. But we can have, let's put green, because like, yeah, I'm happy with these ones. I can have fractions until I get to number 1. When I get to number 1, it's like, nope, we don't want that either. And then I can have a bunch of positive whole numbers to be my base. Okay, so those are, yes, my base can be positive. Yes, my base can be fraction, but it cannot be zeros and negatives or 1. That's for the base. And we saw examples where the base was fractions, right? Okay, let's go back here. Describe the allowable values for A. So can I have positive numbers? Yes. Can I have negative numbers? Nope. Can I have 0? Nope. So all I can have for A is positive numbers, right? We don't want negatives and we don't want 0. We just want positive numbers. So there is a summary of our conclusion based on all the experiment of examples we did here. Okay. Now, if you are one of those students that kind of like, Ms. Myers, can you prove it to me? Why 0 to the 0 power is also not 1? I would love to do that. You can come to my intervention hours and I can show you that. Okay. And that's it for today. Okay, so have this ready so we can jump into actual logarithm, because honestly, the word watt power has a symbol for it. Okay, we want to use a symbol for the watt power. And for that, you're going to have to come for the next lesson. Okay. All right, guys, good job today. Great work. See you later.